Sorry.
Welcome to the session on, but it came that way. I'll be the moderator. It's Phil Walsh. I'm the chairperson for the region. So I'll be the moderator for this session. So if you have any questions, just put those over in the chat. And at the end, I'll read the questions out to Adam to answer. So with that, the presenter is Adam Haroz with Conversion Technology, and he's going to be the speaker. So Adam, all yours.
All right. Hello everybody. I think everyone can see me as I deal with my screen. So we're going to be talking about machine guarding. I have labeled this presentation, but it came that way. As I'll explain kind of more in. I do have my camera on, so you can kind of see who I am and what I look like. But this presentation is going to be exploring the roles, responsibility, and basic information around machine guarding. You'll see I will talk about mostly mechanical style guards, but I'll try to touch base with all that. I'm going to have my notes up on my screen, so if I miss any questions or anything like that, just please post them in the chat, and Phil will handle all that. So without ado, again, my name is Adam Haroz. I'm the engineering manager here at Conversion Technology, or CTI. We are an environmental and safety engineering firm located just outside of Atlanta, Georgia. Just real quick, our specialties include environmental and safety compliance, especially on the OSHA side, robot safety, things like that, with a big push right now on process safety and combustible dust around the NFPA deadlines that just passed, and the next one that's at the end of the year. So a little info on that. So the scope of the things we'll be discussing, I'm going to go over kind of the basics of machine guarding, as well as what the regulations and standards out there say. I'll look at the American standards and regulations, as that's where we're typically in. I will do some comparison with European standards, just so you can kind of see a comparing back and forth, or if any of you have multinational facilities and companies, it'd be good to know. I'll show you some of the issues I've run into with machine guarding, kind of what makes machine guarding so difficult at facilities, who is responsible for what, and then I'll show you some machine guarding solutions that I've run into. So I've labeled this as, but it came that way. It comes from how this whole presentation came to be. Was as a third-party consultant, I get a call when a client gets any safety issue or order to conduct audits, or in this case, OSHA showed up on site due to a amputation. I think the guy got to tip his finger, pinched off a little bit, and they got citations on a piece of equipment that was about a month old due to machine guarding issues, and the facility owner said, "I don't understand, but it came that way." So it kind of got my whole process thinking. I am a mechanical engineer by education, so kind of got my mechanical brain coming through. Some other phrases I hear as a cultural gap of understanding kind of the safety thing. A lot of us in the industry are pretty aware of the culture of safety. So things like, oh, it came from the factory that way. Or, we just don't have good guarding because the employees don't put guards back. Or, well, I just can't guard that. That just doesn't make it, that's not possible. So these are the things that I hear on site from facility owners, operators, maintenance techs, stuff like that. And I'm hopefully here to show that there are possibilities out there, and we'll go over some of these solutions. So to start, I'll go over the basics of machine guarding. I think most of us know, but just so we all have the same definitions in our head. According to Wikipedia, a machine guard is a precautionary safety feature on manufacturer or other engineering equipment. Basically, a guard controls the interaction between the operator or bystander and the machine. A lot of the ones that we use can be looked at like a shield or protecting device to prevent the accidental exposure to hazards. Some of the main hazards that we look for are hazards at the point of operation, ingoing nip points or pinch points, power transmission, and other moving parts. One of the assessments I regularly do is I'll do a robot system assessment. And in those, yeah, there's pinch points, but then we look at parts falling, heat, noise, um, you know, being hit by a robot or things like that. So depending on your equipment, your process, your area, your industry, some of these hazards can be added or taken away. So just some examples of ingoing nip points and pinch points. We have on the top left just some chain and sprocket assemblies, some conveyor belts on the bottom right. I'll show you some examples of those. Those are the typical pinch points that we see that require typically a fixed guard, and I'll show you some examples of that. So these are examples that I've taken at facilities that I've either helped do the risk assessment, gap analysis, or worked with their maintenance personnel or third party to build the guards for the facilities. So this is at the end of a lumber transfer deck where the chains that move the lumber basically have teeth that would come out and around those round sprocket locations. So we had some issues with that because if you're not paying attention and you back up at the wrong time, you're going to get a nice chain tooth kind of hitting you in the back of the head. So what we did is we put a hinge and a fixed guard. I'm a big fan of hinges. You'll see some of my examples from that because pins and hinges tend to be put back on properly versus some tools that may be required make it a little bit more difficult. So that's the assembly closed. Another example is that another type of lumber cant transfer deck. So this is the motor drive belt, had the chains and sprockets and drive belts fully exposed, mainly because lumber is transferred over the guard. So what we did is we did a guard that is easy to grease, easy to remove and put back on with the pins and hinges, as well as does have some exposed chain on top to allow the lumber to smoothly go over the assembly. The thing I always try to point out about this one is this works because the maintenance staff at this facility is phenomenal. So as you can see, they very regularly have to fix some bumps and bruises that these guards come into, and the employees are pretty good about letting it be and letting maintenance deal with it. So it's all about the culture of each facility. Just a quick example of a very common drum and conveyor belt with a pinch point, pretty common with exposed rotating shafts. Just another example of pins and hinges. Really easy to take off, really easy to put back together, and completely guards from the rotating belt. Obviously, everyone's always aware of a nice chuck guard on a drill press. Having worked in a machine shop in my younger days, I know it can be really tough to work with these, but it is required based on the rotating piece of equipment or any other tools that could be assembled. So I have mentioned a lot about the safety or the culture of the safety at a facility. So I wanted to show an example that I've run into where employees are some of the smartest people that can deal with these machine guards because they know how to bypass the guard. So this is an example at a twine manufacturing facility where very regularly they have to take the last bits of twine off the rollers that it's on. So they made this machine, which is hydraulic pressed cylinders that go through and push the twine off the drums and cylinders that they're on. And what happens is they would close that plexiglass lid, which would signal to the equipment, all right, the interlock is closed and it is safe to operate. Well, I talk to the employees and they regularly have to mess with the cylinders to keep it in position during operation of this piece of equipment. So what they did, which is pretty ingenious, if I say so myself, is they just straight up zip tied that interlocked closed. These were some examples of the mechanical guards that I've dealt with. I do want to bring in additional safeguards. You'll hear machine guards typically referred to as the fixed guarding, the fencing, expanded metal type, but there are additional safeguards that can be used as secondary. So for instance, an area scanner, like in the top left picture, that once you activate or once you access a certain area, the area scanner would identify you and either shut down or slow down equipment. A light curtain, which is kind of an on-off version of the area scanner, and then of course a gate interlock, kind of like that hydraulic cylinder equipment that I just showed with the zip tie. Is an interlock is good because if you open a door into a cage, it's going to shut down equipment automatically, and you have to reactivate the interlock to get the equipment going. So those were just some basics of the machine guarding kind of that I've seen in my experience. I do want to go over some of the machine guarding regulation and standards. Real quick to differentiate between a regulation and standard. So OSHA writes the regulation, which is a law. And then we'll go over someone like ANSI who writes the consensus standard that OSHA can pull from and they can deal with, but it's not specifically a citable law. So I will kind of compare those two. And there's plenty of consensus standards to go along with the OSHA regulation. So OSHA's machine guarding, if you look in Code of Federal Regulations 29 CFR 1910-212, it basically states that one or more methods of machine guarding shall, which is basically says must be provided to protect the operator and other employees in machine area from hazards, such as those pinch points and things we discussed. So that's basically OSHA's way of saying if there's a hazard, you need to guard it. OSHA does also have a national emphasis program on amputations, which is their focus on machine guarding. And OSHA's definition of amputation has changed over the last few years. Pretty much that any piece, even a fingertip, if it gets cut off, can be deemed an amputation. So if any of you have been visited by OSHA or have been phone called by them, or if you look on their industry search page, you can see that OSHA representatives have shown up to facilities due to their emphasis on amputation. So they're there to look at machine guarding. A nice little further deep dive into 212 is the point of operation of machines where an employee can be exposed to injury shall be guarded. We kind of said that. It does state the guarding device shall be in conformity with any appropriate standards. That is a very nice generic phrase for OSHA to say, well, we can use the ANSI standards or any other consensus standards. It's typically going to be a lot from ANSI, but unless it's like machine or process specific, that can specify that the guarding needs to meet these. So I do a lot of work in combustible dust. So if OSHA were to show up and say, well, you have a potential dust explosion or fire hazard with no guarding to prevent access to that hazard, they can say, well, you're not in conformity with NFPA standards. But that's a whole different boat for OSHA to go into. So it's not just understanding OSHA's regulations. It's a good mix of OSHA, ANSI, best management practices, national emphasis programs. It's kind of a long laundry list of things to just keep in mind when looking and designing guarding at your facility. So I mentioned OSHA's NEP, National Emphasis Program, on amputations. That is basically going to be based on past incidents, OSHA's understanding of machine guarding requirements, which they have a pretty good one of, and then of course amputations being a giant issue in safety throughout manufacturing. So the NEP allows them to do more focused citations and more focused visits and have kind of specialty outreach and targeting for that. So that's something I would recommend reading it. I think reading 212 and reading the NEP on amputations would be a very good kind of awareness training for yourselves. Those of you that are in the safety field, especially if you're VPP facilities, you're pretty in the know of these things, and it'd be a good kind of jumpstart into the training of more with machine guarding. So ANSI does have the machine guarding outlook as well. ANSI being the American National Standards Institute, they're the ones that write those standards on how to when to replace your hard hat and certain PPE stuff. There are standards a little bit focused on machine guarding, but ANSI takes the approach of doing a risk assessment. I'm on the ANSI committee for R1506, which is the robotic safety standard, and risk assessment is our primary focus. So you can look at the ANSI B11 standards, which are going to be more machine specific and best management practices. Kind of ANSI B1119 serves as the umbrella standards for all machines. So kind of that's the starting point from the ANSI side. It does establish requirements for the design, construction, installation of equipment, as well as operation and maintenance of safeguarding. So with that, there are the ANSI standards that basically say suppliers and users are required to perform a risk assessment. I will get more into the risk assessment a little bit later, but when I say risk assessment, it's kind of interchangeable with gap analysis, JSA, job safety analysis, JHA, job hazard analysis, kind of whatever your method for identifying hazards and then coming up with a plan to minimize or mitigate those hazards. So that was kind of the U.S. side of standards. I know we all love talking about standards and regulations, but just a brief glimpse across the pond to the European Union machinery directives for machine guarding. So the EU has a little bit of a different approach. We saw from OSHA. OSHA looks at the employer, the end user. ANSI kind of sprinkles themselves throughout. But then the EU takes a little bit of a different approach. So they say in Machinery Directive EN 60204, the machine must be designed and constructed in such a way that is acceptable use for its intended purpose and can be operated. The big thing, taking into account the possibilities for foreseeable misuse. That phrase right there is kind of the difference between US and EU, and Canada kind of falls in the middle a little bit, but that is taking into account foreseeable human error, foreseeable equipment or product errors that could pose more risks. And otherwise, if the risks of moving parts can't be engineered out in that design phase of the equipment, the machine should be equipped with protective guards. So they do put a little bit more focus on the OEM side, the equipment manufacturer. Other things in that directive is we talked about the safety requirements, conducting a preliminary risk assessment. So the EU directive states, and anyone with robots, by the way, that that ANSI standard is a little bit different in that both of those, the OEM or manufacturer is required to conduct a risk assessment, but that the end user, you guys, your employers, your facilities, are also required to conduct a risk assessment. The big difference why those won't be the same is the OEM is not going to know exactly where you put it in your facility if you have conveyors going in and out of it. So that's where you take your approach to say, well, this is the part of the process it's in, the part of the facility it's in, how my operators and training deal with this. So we might have to alter or add machine guarding. So kind of what makes machine guarding so difficult? Obviously, there's the differentiating between the standards that we just went over, but machine guarding related injuries pretty much every year fall within the top 10 of OSHA citable and otherwise injury causing issues. Some of the other ways that it gets to be difficult, we're going to kind of go through some of these, is when a lot of people say, well, it's too expensive to properly guard equipment. I do a lot of machine guarding design with maintenance supervisors at sawmills here in Georgia that I work with, just because of the high vibration of equipment, the heavy duty requirements of it. And I mean, the price is it's not something just to pass by, not including my time, but then just equipment costs and installation costs, things like that. People saying that they want their guards and equipment to kind of be multifaceted, to act almost as a platform and a guard. The thing that I'm going to talk about in detail is when an OEM or distributor or whoever you buy something from says, oh, it's compliant. Or I'll tell you my favorite phrase is it's OSHA certified. Those of you that have heard that, hopefully you're kind of chuckling a little bit like I was. Or the it's not my responsibility, or how do I know what guarding I should do? So we're going to go through a few of those pretty quickly. Cost. I really like this slide. I think I got it from the Bureau of Labor Statistics. But so the average workers' comp claim based on an injury from machine guarding or amputation, things like that, is roughly around $21,718. So that's just the workers' comp bill from that. So if you look at it from the business side of it, the upper management side of things, is if you assume a 5% net margin, which is pretty good, you take your sales with that 5% net margin just to make up that $21,000, you're looking at about $435,000 in sales just to pay for that workers' comp claim. That's not including any OSHA fines that could come with it, having to hire someone like me to come in and do an assessment with you, increases in insurance, administrative costs. If you have a big name company, negative publicity can be quite damaging. Decrease in employee morale is pretty important. I think a lot of us know that just from working with our people, that if they're not feeling good, they're not going to be happy, and if they're not happy, the work suffers. We kind of know that. So a lot of times we also have equipment that we want to be multifunctional. We want our guard to act as something that is very low cost, but also effective, and also doesn't break down, and is also able to withstand our equipment for the next 10 years. So it's you see that Swiss Army knife is you kind of got to give some to get some, but then it's going to come into, well, the equipment itself, the guarding itself, then you got to look at operators, maintenance, culture, training. So all those come into place. So when you try to add too many constraints to a piece of equipment, it's going to suffer. So you kind of want it to be as streamlined as possible, but effective, to me personally, is the priority. So as we know, certain equipment can pose different types of hazards. For instance, this is just a chip belt. You have the rollers that are less than 7 feet off the ground, posing pinch points with the conveyor belt. This guarding potential, if somebody decided they want to jump in and go into the hog, that has its own hazards. This trip hazards, noise hazards, things like that. So it's a multifaceted approach when looking at the equipment. This is an example I got from a client of mine. This is the example of, oh, well, it meets OSHA requirements. It was a bench grinder, standard bench grinder that we see in most facilities. I was doing a safety audit of the facility, and I made some comments that there was no tongue guards or work rests on the bench grinder. And again, but it came that way. So this was from a reputable sales distribution company that sends you their catalogs in giant books with yellow covers. I will leave it at that. This was the specific bench grinder pulled off that manual. It says meets OSHA requirements. Doesn't specify all OSHA requirements, but the problem is he had ordered it and it came in with no work rest and no tongue guards. So therefore, it actually doesn't meet OSHA's requirements specific for bench grinders. So things to keep in mind is read the fine print. I will say OSHA does not certify, quote unquote, certify anything. I used to maintain my OSHA 10 and 30 hour training as a trainer. Even that, they consider it authorized. It's not certified. So be weary of the fine print. Don't always take the OEM or salesperson's word for it. Read the standard, kind of know what you're getting. Those of you that in the safety realm of your companies, it's important to kind of know what you're getting and know kind of what OSHA is going to look for. And hopefully these slides and this presentation is going to help with that. One obviously big issue is failing to identify and assess the risk of your equipment. I did put ANSI B11, technical report 3. I think that's old. It has been updated since then. I apologize, everyone. To identify kind of the how and why of conducting a risk assessment. Robot people, also ANSI R1506 has technical reports on that. Kind of same but different. So just know the equipment you're looking at. The thing about a risk assessment is only hazards that have been identified can be abated. If you don't know they're there, it's tough for you to come up with an action plan. So with that, having a good team to identify the risk, really doing a thorough, comprehensive risk assessment. I'm not a big fan of just checklists that you can check off, turn in, and say, we did the risk assessment. To me, that's not comprehensive enough. It is not a cookie cutter approach. That's a better way of saying it. And then the way to do risk is you can calculate your risk by severity of harm times its likelihood. So something could be not very likely, but if the severity of harm is death, that high severity and low likelihood meet in the middle, and you can have a pretty moderate risk, and vice versa with something like that. And if you do get high risks, I do want everyone to know that it is okay for you to meet with upper management or have your team get together and state, well, a low risk, not that there's no risk, but even if you have a low risk due to low likelihood and potential low severity, well, we can consider this an acceptable risk and just hope that your training is good and the operators listen to stuff and signage is working. As you get higher, pretty much above a low risk, I wouldn't deem it as acceptable. But that's up to you guys. It's just really if something happens or an injury or accident, it's up to you to kind of prove, well, this is how we came up with an acceptable risk, and this is why it is, and this is why it failed or not. So which standard do we want to look at? There's the OSHA regulation and there's the ANSI standard. As I said before, so OSHA's the group coming in and they're enforcing the law. They're enforcing their law. They're the ones that can issue citations. They're the ones that can shut you down. They're the ones that you will have to go to court to fight. So kind of the OSHA regulation is the bare minimum, I would say. And OSHA does put the responsibility on the end user and employer because that's who they're looking at. So if you want to say, well, it came that way, and they're going to say, well, you should have done your risk assessment. And ANSI does put more responsibilities on the OEM side of things, which I think is fantastic. But you kind of got to meet in the middle with that responsibility. The big thing with a risk assessment, why I keep mentioning it, is I've been involved in quite a few OSHA informal conferences and OSHA meetings based on citations, violations, and fines for my clients. But a risk assessment is going to be one of the best forms of due diligence. Big word for OSHA, due diligence, to proactively tackle the potential hazards around your equipment, prevent potential injury. And then if you say, it's crazy, this person got hurt, we deem this as an acceptable risk. Without that risk assessment, there is no proof as to that you did something, why you did it, how it is. So that due diligence aspect is going to be a major player in decision making, kind of above any of us that are on site. So after all that, really, who is responsible for guarding? Is OSHA responsible for telling you how to guard? Is ANSI responsible for telling you which guards to do and what? Is your bottom line, your key decision maker? Do the operators tell you what they want to do and how they want to do it? Or is upper management and CEO the person saying, this is how I want it done? I've seen people that follow all of these. So as we said, ANSI takes the role of both the OEM and end user, to conduct the risk assessment. OSHA takes the approach of the employer has the obligation to protect workers and keep a workplace free of hazards. Those of you that deal with EU standards, which can be when you have equipment from The EU, it's actually to me, it's easier to transfer EU style guarding and signage to the US versions versus the other way. EU does also require the risk assessment, safety through design being a key aspect, kind of engineering it out before it shows up. I didn't mention too much the CE markings or here UL markings. It's a good method. I don't take the OEM's word for it. So I always like to assess something in how I view things and my err on the side of safety type. So with the who is responsible, it's, new equipment purchasers, those that are purchasing the equipment at your facility. It may not be you guys, it may not be the operators. They often assume that the OEM dealt with it before it got on site. I do have a client who's an OEM, and they're fighting with someone who just didn't think the guard was adequate enough. So it could be a back and forth that you have with your equipment rep or distributor, whoever that is. But again, the OEMs don't know your process and your facility as well as you guys do. So they do kind of get a little bit of a pass from the regulatory side. And when in doubt, ask that OEM and manufacturer, hey, can I see the risk assessment that was conducted on this equipment? It may not be the same style as y'all's risk assessment, but it can shed some light. It can show some potential hazards you may not have thought of. And then for the employer, remember, as employers and end users, we're the ones paying for any fines or citations. Or if there's an incident on site, it's going to be our employee getting injured. So I recommend doing a risk assessment, or what I do with our clients is risk assessment, JHA or JSA, or even a machine guarding gap analysis. Just pretty much a risk assessment, just looking at machine guarding. So I definitely recommend doing that for every piece of machinery. If you move pieces of machinery, I think it's a good idea. Obviously, that first time's to be pretty big of a job, but you have good people on staff. You have operators. You can bring people in and out to review those and look at it. So basically, what I'm saying is it is everybody's responsibility for good and adequate machine guarding. So pretty much everyone involved in the design and operation, so that's the OEM and as an end user, is responsible for the adequate installation and use of machine guards. So the proactive approach is that risk assessment. Machine guarding is, you can look at it as an investment in your equipment and employees, not just an expense. I think a lot of us regularly find, what's the return on investment for safety? Oh, I got to pay this consultant to come in, and I got to pay $250,000 for guarding for my whole facility. Yeah, but if you prevent even a few injuries, isn't that, is that worth it? So just some solutions. So kind of the what do we do now? So I went over just some examples that I've dealt with or built, just what the regulations say, the overall responsibility. So, and again, as a consultant, I deal with this part pretty often. Ignorance is not an excuse. You saying you didn't know something had to be guarded does not mean it doesn't have to be guarded. Oh, you weren't aware of the hazard? Well, the hazard existed. So ignorance is not an excuse. OSHA is not going to accept it. I don't think a person who gets an amputation. I'm echoing. So when looking at solutions, okay, that's better. When looking at solutions, you want to obtain that risk assessment performed by the OEM, conduct a risk assessment at your facility, like I mentioned. Get help from a third party is always acceptable. Obviously, as an engineer and consultant, I like this. I like being the outside set of eyes that's looking at equipment kind of from my purview, not something that I've walked past every day. OSHA compliance assistant specialist. So you can call OSHA, and they do have free consulting. A little word of caution with that is they are still OSHA, so they will provide the consulting for free, but then you kind of have a timeline to mitigate those hazards. Otherwise, you may not like the outcome. So an engineer can perform a hazard analysis to determine, like I mentioned, and then when in doubt, I mean, you have, that's the next slide. You have a great staff of employees. Use them. I'm a big fan of bringing people in from all departments to be part of safety committees and audit teams.
Your video stream has been disconnected.
What? Oh, hello? Sorry, that was weird. So use your employees. Your operators are the ones that are either going to be working around these guards. Your maintenance may be putting them on and taking them off. Your operators are typically going to be the ones, and maintenance, don't get me wrong, are typically the ones bypassing these guards when they want to get through something. So use your team. I recommend bringing people from other departments to look at these guards because they'll have a different view. So I've mentioned a lot of things. So the hindsight or the put the blinders on of what to just specifically pay attention to is machine guarding and the safety.
Adam, we're not hearing your audio.
Oh, you're not? Oh. Uh-oh. I am logged off. Hello? Hello, can you hear me? Can you hear me? No, I lost audio. Weird. Oh, can you hear me? Oh. Hello? Oh my God. Yep. Yeah. Microphone. Okay. Well. Sorry, everybody. My gosh. All right. Can everyone hear me now?
We got you back.
All right. Great. Sorry, I don't know what happened, everybody. Let me go back to this. Well, I'll just show. I was at the end, but I just wanted to kind of go back over the things to remember from what I mentioned. Hopefully, you guys heard all that. So machine guarding and the safety of employees is everybody's responsibility, top down, bottom up, however you want to look at it. Get help if you need it. Use a third party, an engineer or consultant. Ignorance is not bliss. So not knowing something does not mean you don't need to know it. And then risk assessment. Don't take an OEM's word for it. Really understand the safety of your equipment at your facility. So if there's any questions, hopefully we heard the last bit. I am here to take questions. I think we still got plenty of time. So I will leave my contact info up while we do this. Phil?
Yeah, so currently no questions in the chat, so feel free to throw your question in there. Adam, I got one I'll throw out there. It's sort of new to me. I've seen one of my facilities recently had a hand abrasion injury.
Mm-hmm.
I don't know if you've seen the situations where the roller conveyors that have the little rollers on them towards the end.
Yeah.
It meets all the OSHA requirements of guarding and the ANSI guarding, But for whatever reason, the employee was waiting on a line changeovers. The conveyor was running, but there was no product running. He was just sort of standing around. And for whatever reason, he decides, well, I'm just going to stick my hand in between those rollers.
Yeah.
He stuck his hand between the rollers and then sort of a carpet burn type on his forehand.
Yeah.
I'm not sure if you've seen something like that.
You know what? It's funny. So everyone listening, we've all dealt with this. I know it's always tough when someone just sees something and says, I'm just going to put my hand here. With that, you can either look. So that's always a tough situation because we can say, well, we need to retrain this employee, or potential, I need to put signs. Don't put your hand here, which I've seen some very interesting signs. Are they automatic rolling, or they just move as product goes over them?
Yeah, they're towards the end there, so they're automatically rolling to move the box on from one.
Okay, so I've seen a facility that had issues like that. There were much bigger rollers. It was a carpet facility, but they ended up switching. It was a capital investment they had to do, for next year. But they ended up switching to only part of the rollers are automatic, but the other rollers only just free move. So they just move as product goes over. So it was kind of meet in the middle a little bit. And it was one of those. It was I think they had a amputation because the guy pinched it because they were much bigger rollers, and they switched to that and it got better. But they also retrained that employee, so it's kind of it's so funny you asked this, but once a year I get hey, we had an employee put his hand somewhere he shouldn't, and you can look at changing the equipment. Guarding is going to be tough. I'll say that. So you almost moved into the safeguard of retraining signage. You can switch to those non-automatic rollers. Those would be my first go-tos without really then having. So then I'd say, you hired me to do this. I'd say, here's my recommendations. Then you would meet with your team and maybe even that employee's supervisor and say, do you think this would work? And if everyone's like, no, none of these would work, let's reassess and potentially, like I mentioned, that could be deemed training and signage besides the point. But then you can say, well, that's deemed an acceptable risk because we've retrained, we have signage not to put hands on rollers. What else can you really do? And then if it happens again, then you kind of got it. It pretty much works until it doesn't. Then you need to reassess where you're at from there. That's what I would recommend from sitting behind my desk, at least. So.
Yeah, so similar to the top conveyor you mentioned, most of the rollers are free rolling except for the few at the very start and end that transfer from one to the next.
So yeah, honestly, that's one of those cases that a fixed guard or some sort of guard may not be the best solution for it. I'm not here to say guards solve every problem, but best we can do, So,
all right, any other questions?
All right, well, everyone, my contact info is up and posted, and I believe you'll get these slides. And feel free and call or email me with any questions you have, or if you need, hey, this is the guard we have, any ideas. Or if you need help discussing or coming up with a topic for machine guarding, risk analysis, or JHA type stuff, you just feel free and reach out. I'm here.
So. All right, great. Thank you, Adam.
All
thanks,
right.
everybody.
Yeah, thanks, everybody. I appreciate talking to everyone. Thanks, Phil.